Okay, so it's 9:30. So I'm gonna start with the basics of visualization, going over loading data and so on. This one is a little more open, so if you want to interrupt me at any point, that's perfectly okay. I'm shooting for having a 5 to 10 minutes open at the end for questions, but if you have a question, you don't have to wait. All right. So when you open the software, it's going to look like this. You can add a well just by clicking there, and it's going to immediately bring this window. What we said is called the well interpreter. That's the official name that we give it. And from this window, we can, well, you can see that now we have it here. It's been added. I can close it, and I can open it from here. In header information, I can change the name. So I'm going to call it basic view, say okay. Now it has a different name. I double click on it. I can open it. It's here. Now I'm going to load some data. So to load data, I just go File, Load Data, or just click in this folder that is opening, which, by the way, now we can load the LIS. In this case, I'm just going to use an LIS. But one of the improvements that we've had in the past couple of months is the DLIS reader works, and it works really well. So here is just showing me all the logs that we have. I'm going to just load them all, but I'm not going to load the entire interval because it's too large. I'm just going to load from 9200 to 9500 bit. I already know that's the area of interest. Click import, and immediately you see that here in the reference track we have the gamma ray. And now, even though it's the most basic introduction, it's going to look different for some of the experienced users. Here in the template, by default, you always will have this triple combo, quad, and fluid flow. We had templates in the past, but now we have them integrated with the curves default view that I was showing you, which, by the way, you can see here in settings, default curve views in the main window. You can see the last window that I was showing you. You can see all the curves that have been defined for bit size, gamma ray, and so on. Now that allows us to just, if you just load data and you say, well, I want to see the triple combo, it takes a couple seconds, and then you see all this. People that have used the software in the past remember that to get here it was 10 minutes or so. Now it's a little faster, and you can always modify this and save it, and it saves in your settings. So it's going to stay there for any new project that you open. I have these three are default, and you should always have them. These two I made myself. Now we have this. We have the gamma ray, we have the resistivity, then we have the neutron porosity and the density. And I know that this is a gas sense case, so I'm just going to add another plot. This is what we call the track editor. You open it either by double clicking anywhere in the track display or clicking down here. This is the track display, sorry, the track editor. We'll open this, and whatever you click is going to open in that track. So I clicked in this track. It's track number 5, and this is the title. Sorry, the title is here. This is the name. You can make it visible or not. You have the scale. You can add a number of plots, and each plot is going to show here as a list. In this case, we have these two, and if you click in any of these little buttons, it's going to show you the controls for that plot. Now I'm going to add another plot, which is the shade, and it looks something like this. It looks good, but because I'm interested in identifying gas, I need to put as the left curve is going to be the density, and neutron porosity is going to be the right curve. So now I see that this area is a little more interesting, and I see that gamma ray is low. I see it's an area that we want to see. So to zoom in, here in the bottom we have some controls. I'm going to zoom in into this area. Now here we are. Now that I've zoomed in here, this is the reference track, and these green things that you see is the modeling limits. You have them up here and you have them down here. So because I don't want to do the modeling in the entire interval. Here I can either just move them like I did, or I can right-click in the reference track, and I get this menu where it allows me to change the reference track limits, the viewing limits, or the modeling limits. There is this shortcut that says set modeling limits to current view. I do that. I say, this is what I want to model. Good. Now, to start building an Earth model from these logs, the first thing that I'm going to do is detect some boundaries, to add some boundaries here. And the easiest way to do it is to use the detect boundaries module. You can use a mnemonic. You can use explicitly the LAS. Remember, I talked about sources. We have, in this case, mnemonic or LAS. You shouldn't use an Earth model property to detect Earth model itself. So in mnemonic, I can use the top we have the most commonly used. So I can use just gamma ray. Again, I'm going a little fast. If you have any specific questions, ask. Otherwise, hopefully, everything is pretty self-explanatory, or we wish to believe that. Then we have the method, which have maximum variance, step function, and so on. There's a explanation of each method here. I'm just going to use the maximum variance with the minimum sliding window of 0.25 and maximum of 2, noise threshold of 20, say detect. It detected some boundaries, but of course I need to plot them. So I'm just going to add it here. It's an Earth model property, boundaries. This is what we got. It's probably a little too few. There might be some here. So I can, if I make the noise threshold a little smaller, maybe I'm going to get more. That's probably better. You can play with this. Each data set is different. The default values that we have tend to be good, but in some cases you may need different values. Now we have some boundaries that looks good. If I want to modify them here, I have these 4 controls allow me to modify them. I can make this slide. I can delete them. I can add petrophysical or physical boundaries. We'll go over them again later. It pretty much got everyone, but let's add just one there just for displaying purposes. And we're going to assume that this is a good starting point. By the way, if I don't like the cursors, if I don't want to see the cursor lines, so those, you see that every time I move the mouse, there are some lines following around. I can open this module, this little window, track display. You click here and you get this window, and allows you to modify the way things look. It has the controls for that, has other controls. I'm just modifying them. I just want to show you that it's here. If you want to explore it again later, that's fine. Okay, so now we have boundaries. Now the next thing we need is let's start generating properties. So besides the gamma ray as a log, we're going to add here gamma ray, but as an Earth model property. Within Earth model property, we have gamma ray. And by default is 1, so the curve is somewhere down there. We don't see it because it's too far to the right. So we're going to use this curve for gamma ray to get a first estimate of what the property should look like. So here I go to populate properties, which is this module, or Earth model populate properties. And I can say gamma ray. I want to populate gamma ray. These are all the properties that we have. And I want to populate it using, I can use the mnemonic gamma ray because I know that's the only curve we have. And just click populate. And you're going to see that now, instead of the line being all the way to the far left, it follows this trend. We have the way that it's done is it takes either a maximum or a minimum, whatever it finds one of those. And if it's a place where it doesn't have, for example, in this case, it didn't find any maximum or minimum, so it just took an average, which is fine. Now I can see that maybe here is not, maybe here I need one extra. And I populate again, and you see how that changes. That's okay. All right, let's assume that what we've done is correct. So we have the boundaries and we have gamma ray. Now, besides gamma ray, in many cases, we want to work with invasion. And now, so I'm going to, I want to see first, I'm going to show you that there is invasion. I probably went ahead of myself a little bit. But here in the resistivity, we have RD, which is resistivity deep. Then I'm going to add RS, resistivity shallow, and I'm going to add RM, resistivity medium. And we can see that separation that tells us there is some invasion. All right, now, given that we have some invasion, we're going to need some radial zones. To view those radial zones and to view that invasion, we can add another, I'm going to add another track, which is just plus sign here. And with that plus sign, I can I'm going to add this plot, which is called the vertical cross section. That vertical cross section shows me what the borehole looks like in the different zones. Sorry. And so the radial limits are from 0 to this number in feet. So I'm just going to make it 5 to make it a little more realistic. So anything to the left is the borehole, to the right is the formation. Now, I can add a radial zone here just by clicking here. Now we have this extra radial zone. And now we're going to populate this. Notice that it's also resistivity. By default, resistivity is 1. Of course, that's just the default value. We're going to modify it. And to modify it, we're going to populate properties, but it's not going to be gamma ray in this case. We're going to use, well, we can leave gamma ray there and just add resistivity. We have resistivity right here. And we're going to do it for the mud, or the borehole. And we're going to use the explicit value because we know that it's invaded with we're going to give it a very high value. And then because we see that the shallow one, so 8010, has the highest value, we're going to give it a high value. We can make it even 1000. Now for the invaded zone, we're going to use this medium, or we can use 8010. Let's use, so we're going to use LAS, and we're going to use 8010. We could have done this by mnemonic also. And lastly, for the formation zone, we're going to use 8090. And I click populate. And when I click populate, you can see the color changed here. And if we add, so let's first focus on this plot, and then we're going to add those properties just like we did with gamma ray. So to view this better, we can reset the limits. Now it's from 1 to 10. It looks okay. The scale, we can make it logarithmic. And this resistivity, it's probably making a little more sense. We see that the invasion makes sense. Where we see more invasion, it looks a little better. If we had used 8030 instead of that, we can see that it would change. The colors would be a little different. Which one is right? Up for debate. We'll leave that there. And now we're going to see also in the resistivity curves, we're going to add the Earth model properties. So Earth model, resistivity, parallel or homogeneous. And now we have this one here. That's for the formation, which is, so it looks this way. It's, and we're going to add another one for the invaded zone. And that looks okay. We can change the color so that it matches the curve that we used. Now we have a more complete model. This would be the very basics of plotting. Now, besides this, I can show you also the general calculator. I want to give you an idea of how this can be used. Let's say that instead of just getting the radius as constant, the borehole radius, we want to use information we have here. So we can use from the LAS, we have the caliper. And let's say that we're going to save it in the same as, we're going to turn it into the radius. Let's call it capital RID. The valid name is just whatever we're going to use here. So I'm just going to call it cal, just for caliper. And the radius is going to be just the caliper divided by 2. If I hit calculate, you can see now that here in the basic view, by the way, you have the radius besides the, by the way, this is where you would see these things. You have the radius and gives you some information. This is a good way of exploring your data. You have the caliper, it tells you the data size, the depth range, the data minimum and maximum. If you compare the caliper to the radius, of course, now it's half. Now, well, this one is in feet. The caliper was in inches. It just got saved in inches, but that's okay. It's actually using the right units. And we can now we can see it. And now that we're just going to add another track to really rapidly just see the radius. So in here, we can see the caliper and the radius, and we see that one is just half the other. I'm going to make this 0 so that it actually shows. And to another cool trick that you can do is just right click on any of these. We call the headers, and you can say snap, and the limits are going to be the same. It says snap inches logs to limits of whatever curve you clicked in. So now you have both of them. It's fairly straight. It's okay. But we can use this to populate the radius. And we could do that by using the populate properties again, like we did before. So it would be, if I open the populate properties, besides all those things that we've populated, we can also populate the radius. Using the borehole radius using the LAS radius. And if you populate, now instead of being a straight line down here, I think you can see it. Maybe if I make this exaggerate a little more, you can see it's not a straight line anymore. It's taking the values that we set up here, and we could, just for the sake of it, instead of that, we could say an explicit value. Or actually, let me just show you that you can modify the radius also by clicking here. You can modify the radius of the borehole. You can modify the radius of invasion. It's modifying the radius of borehole. That's okay. That's okay. Another way we could have done this is, instead of saving it as a log and then populating properties, we could have saved it as an Earth model property and just radius here. That would be a shortcut. If you do that, it sets up the radius to what we had. I set invasion radius, so that's why it took everything from the other, so that's okay. And lastly, we have a lot of Earth model properties, as you can see. It's a long list already, but sometimes people don't find the property that they want, or they want just custom properties because they want to test different scenarios and they want to save them as different Earth model properties. So now we have this option to add Earth model properties. You just click here and ask you if you want to add a property. You just say add property. What is the name? What are the units? The type. If you forget the types, we have help for the types, which is what we were talking about at the beginning during the first talk. And you just say okay. Okay, and now you have an extra property that you can use or you can use to visualize or any of the other